All right, here we have a little bit of a weirder function to look at, but let's see what happens. What can I compare this to? Either I'm going to change the top or I'm going to change the bottom. I kind of want to stay away from changing both of them because that introduces too many changes and it's harder to tell what happens. So let's figure out things to compare this to. My first thought is just to slightly change this. So I could compare to 1 over n factorial. This denominator is definitely smaller than that one. So this whole fraction is definitely bigger than this whole fraction. Okay. So that's one thing, but then that's still weird, so I'd have to figure out some other stuff there. Well, I'll just write out some more stuff. I could compare it to 1 over n. This factorial is really, like, it increases very quickly because it's going to be, well, it's going to be whatever times all the numbers back down till 1. N is just n. So this is definitely smaller than that, which means this is bigger than that, right? Hopefully that makes sense. And that's a p-series, but I also know this is, for me, from experience, n squared. And maybe I'll need to use this one. This n squared is eventually smaller than any factorial. The factorial grows faster than exponential functions eventually, so it's a very fast growing function, the factorial function. So n squared is something that I can look at. And the reason I picked both of those, because these are both p-series. This one, p is greater than 1, so it converges. And this one, p is not greater than 1. It's equal to 1, so this diverges. And this one, I have no idea. I would actually have to use, if I compare it to this, I would have to use another comparison test for that. So I would have to, like, okay, compare this to this, but to figure out this one, I need to compare this to that. So might as well just compare this one originally. Let's see. Okay, so, and I don't know which one I want, divergent or convergent. I have no idea, so I'm just going to start with this. 1 over n plus 1 factorial, and I'm comparing it to 1 over n. Well, I know, first of all, factorial grows very, very quickly. And n grows linearly, so this is definitely smaller than that. So if this is smaller, then this fraction is greater. So we have that. So this one's greater than this one, which means I have my greater function, and that diverges. So that just diverges up forever. So actually, I don't know whether this one converges or also diverges. I have no idea. So this does not help at all. Well, let's hope that this, well, I already said, so this one's going to be the one that we use. 1 over n plus 1 factorial, and I'm comparing it to 1 over n squared. Now, here's where I have to convince you that the factorial is definitely bigger than n squared. If n squared is smaller than this, if n squared is smaller, then the whole entire fraction would be bigger. And that's what I want, because if the bigger one converges, the smaller one is bounded, so it also must converge. So let's see. How can I convince you that? I want to show that n plus 1 factorial, I need to convince you that n plus 1 factorial is what? Bigger, larger than n squared. This we can just inspect. Now we don't know how to, like, I mean, I could just plug stuff in. The first thing that I'm going to plug in is 1, right? So if I plug in 1 and 1, okay, that doesn't help. If I plug in 2, oh, sorry, that would be 2. It's already bigger, right? If I plug in 1 here, I get 2. So that one works. Remember, it needs to eventually be bigger than this one. It doesn't matter like if it oscillates. That was the first part that I talked about in the first video. Okay, so let's plug in 2. 2 plus 1 is 3. 3 factorial is 6. 3 times 2, 6. If I plug in 2 here, I get 4. So definitely bigger there. And then eventually this one will run away. Like well, let's see. So this is n equals 1, n equals 2, n equals 3. So that's 4 factorial. 4 times 3 is 12, times 2 is 24. And if I'm plugging in what? 1, 2, 3, and 3 squared is 9. Of course, okay, yeah, this is bigger. Every single time, it's bigger than that. So, and it's just going to keep getting bigger and bigger, and this is going to steadily get bigger and bigger. But the factorial gets bigger faster than any polynomial, actually. Like any polynomial. Eventually, the factorial will always win. Eventually, if we're going to infinity. So that's something to keep in mind. Factorials grow extremely quickly. All right, so hopefully I've convinced you of that. So that means if this is smaller, then this entire fraction is larger, and that's what I wanted, because the larger one converged. So we can say that this, I'm not going to write it down this time because this video is already taking too long, but we can say this series converges because in comparison with that series, because 1 over n squared is smaller. And there you go. I think maybe the justification, if I was going to put this on like my answer for an AP free response, I would say I would like maybe figure it out for myself, but the justification is that factorials grow much, much faster than n squared. You don't have to prove that, but you do have to know that. And if you don't know that, come up with that and then state that, because that's the thing that's providing this fact. All right, we're done.